Okay, so again, today we're talking about trigonometric ratios. So there were 3 trigonometric ratios.
Put it on screen.
Whoops, I just reversed those letters.
Mr. Spizak, thank you.
So again, trigonometric ratios. So there are 3 trig ratios: sine, cosine, and tangent. Now, the good thing about this section is these 3 ratios are actually given to you on the FSA. And I believe they were in this format. I think they actually also spell out the words completely instead of just abbreviating like I'm doing, but so again, sine of an angle is equal to opposite over the hypotenuse. Cosine of an angle is equal to adjacent over the hypotenuse. And tangent of an angle is equal to opposite over adjacent. Now, out of all the things they could have given you, I don't know why they give you these, because for the next few years, you have to have these memorized, right? Algebra 2, you have to have memorized. If you take trig, you'd have to memorize them. Pre-calc, calc, you'd have to have these memorized. So, out of all the things they chose to give you, they chose to give you one of the easiest things, I think. Because, again, we have lots of ways to remember them. And if you know them, and instead of having to look them up every time, it helps save time. So, I recommend still having to memorize this year. Again, SOHCAHTOA, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Also gave you the saying, some old hippie caught another hippie, tripping on acid. Again, different ways to remember it. But again, you need that for the next few years. Now, when do we use these ratios? We use them for what type of triangles?
The right one.
For right triangles. Any type of right triangle. Now, you have to have 3 parts in order to use these. So, use to find missing parts of right triangles. Now, again, you must have 3 parts. Must use 3 parts. 2 sides, which again, those 3 parts must be 2 sides, 1 angle. Now, specifically, you use these for only the 2 acute angles as well, right? So, you can't have the right angle. That doesn't help us. We have to know it's a right triangle to begin with. But then you have to be given 1 of the angles and 2 of the sides. Now, out of those 3 parts, 1 of them can be missing. It doesn't matter which part's missing. But as long as you have 2 sides and 1 angle, and out of those 3 pieces, 1 of them's missing, you can use the trig ratios to solve. All right, so let's set up a triangle here using our ratios. So I'm going to draw a triangle. I'm going to label this as angle A. This will be my right angle. Across from A will be lowercase a. Next to A, I'm going to put lowercase b. And the hypotenuse I'm labeling as C. And I first want to identify the sine of A, the cosine of A, and the tangent of A. So, sine of A. What would be the ratio using this triangle for sine of A? A over what? A over C. Can somebody let them in? Please. All right. So A over C, which is, again, opposite over hypotenuse. Cosine of A, which is B over C, adjacent over hypotenuse. Again, adjacent is the one that's next to. And then tangent of A over B, opposite over adjacent. Now, there's some other things that we should know if we were to identify the sine, cosine, and tangent of what I'm going to call angle B, which is going to be this top angle here. Thank you. So now, for the opposite angle, there's certain things that we should know. There's relationships between the sine, cosine, tangent of one of the 2 acute angles, and then the sine, cosine, tangent of the other acute angle. Could you let him in?
No.
Huh? Well, okay, wait. So, sine of b. How does sine of b... Shh, guys. So, hypotenuse will always stay the same. But sine of b, how does that relate to the original values we have here? Cosine of a. So, again, the sine and the cosine of its complement, because these two angles are always going to be complements, because the two acute angles in any right triangle always add up to 90. So the sine and the cosine of its complement will always be the same. So this one will end up being b over c. Cosine of b would be the same as sine of a. So that'd be a over c. And then tangent. How does tangent of the other angle relate to tangent of the other acute angle? It's reversed. It's the, what do we call that when we flip a fraction? The reciprocal. Yeah. So b over a. And again, if you look at the triangle to identify that, again, basing off of angle b, opposite over hypotenuse, b over c. Cosine, adjacent over hypotenuse, a over c. Tangent b, opposite over adjacent, b over a. You what? All right, so now, we're going to go through a couple different problems. Some of them are going to use this idea that I just went over. Some of them are actually having you solve for different sides. I think we can get through all the examples I have. Again, every example that I am using during these few days, in case you weren't here yesterday, comes from our previous test. So I just pulled test questions that I've given you guys, and we're going to go through them. Anybody need these notes before I take them down? Well, you need like all of them because you just got here, right? Yeah. Okay, I'll give them to you to look at. Here. Let me put up the first problem. So, the first problem, that I put up here, we're looking for sine, well, sorry, we have different parts given to it. Sine of 8, sine of 82, cosine of 45, cosine of 35, and sine of 30. We want an equivalent trig ratio for each one of those. So, how do we identify an equivalent trig ratio for each one of those?
Wouldn't you make anything that's sine make it cosine?
Yes, so all right, so first step, anything that's sine, you're going to use cosine. What's the second step?
Then aren't you going to take the degrees and subtract that from 90?
Yeah, take whatever the degree is and subtract it from 90. Because again, the sine of any angle is equal to the cosine of its complement. So, sine of 8 would be equal to cosine of 82. Sine of 82 would be equal to cosine of 8. Cosine of 45 would be equal to
45.
Sine of 45. Cosine of 35 is equal to sine of, try again, 55. And then sine of 30 is equal to cosine of 60. We need some practice subtracting from 90.
I was doing mental math and my brain is already.
So again, could you have a question like that in the non-calculated part? Yeah, again, all you're doing is subtracting from 90, so work on subtracting from 90. But again, whatever the sign is, again, the equivalent would be the cosine of its complement, so subtract from 90. All right, that's it. Remember this? Again, you're always subtracting from 90. Always subtract these numbers from 90. That gives you the number, and then opposite value. They always have to add it to 90. Again, sine of an angle will always be equal to the cosine of its complement. All right. Next. This one's setting up ratios. But before we can set up ratios, you have to do something else. What would we have to do first? Figure out the bottom. So, there's a couple different ways you can figure out that bottom. And it's based on what we did yesterday in class. So, take a minute. See if you can solve for the bottom side first, and then set up your ratios. Again, when you set the ratios, you just leave them as fractions. No, it's one of our special, aside from one of our diagonal triples. Yeah, it's not one of the two that I wrote them. Because again, there's other ones that come up a lot. This is one of the other ones that you will probably see at some point on the essay. So you can use Pythagorean theorem to solve for it.
No, I don't know those. You let my
Shoes?
Wasn't right. No.
Why do you have two completely shoes?
It might depend. I did that in 7th or 8th.
It's not even like one with. They're not even both the same. One's a gym shoe and.
I don't know, because I saw your hand and then I didn't see where it
Very much smaller than that. So you're trying to put all your notes on one piece of paper? Really? Yeah, that's what I'm waiting for, but you know. Yes, some of you guys are still going back over notes and stuff like that. Alright, let's do the easy part. Make sure everybody's on that page first. So, on here, what's the missing value?
15.
15. How do you know it's 15? Pythagorean theorem, or it's a Pythagorean triple. Alright, so this is an 8, 15, 17 triangle. If you don't remember the 8, 15, 17, use Pythagorean theorem. So you'd have 17 squared equals 8 squared plus 15 squared. Okay. So then, 17 squared is 289. 8 squared is 64. Oops. Whoops, sorry. I didn't mean to put the answer already. Let's put B here. My bad. Subtract the 64, you'd be left with 225. Square root, and you get 15. Right, so again, once you know that that bottom side is 15, then you're doing your ratios. So if you haven't done your ratios yet, try to set up your ratios.
Set them up, I just didn't feel like doing an actually.
There is a common mistake that I'm seeing. So, double check your numbers. Double check your angle. Sine of A. What is sine of A here?
8 over 17.
Nope.
No.
That's a common mistake. That's a common mistake that I keep seeing. It's 15 over 17. And the reason why it's that is because, notice, yes, you just took notes. And yes, I set up this triangle in that direction. Is that facing the same direction?
Yes.
No. A is in a different spot. Again, you got to look at, we're looking at angle A. A is up here this time. So since A is up there, this is now opposite, this is adjacent, and this is hypotenuse. Well, see, that's why, again, you have to know these properties. You can't just go back to your notes and look at these, because again, if you're looking at the notes, you'd be like, hey, that's the one that's opposite, no. Again, you gotta know how it works. So again, it's based off your angle. This is opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse. So cosine is then 8 over 17. Tangent is 15 over 8. And that's it. All right. Let's move on. All right. Again, still. So again, all the questions that we've looked at so far, including this one, still on non-calculator. All right. These. So now, this one's asking you. This one's asking you. Which ones could you use to solve for the angle? They didn't give us any angle measures, except for telling us that's a right triangle. But they gave us all the sides. They want this angle, L, down at the bottom. So first, take a minute, see if you can figure it out on your own.
Wait, what?
Which one of those would give you the answer for angle L? Yeah. Remember why we use the negative one?
Nope.
Means.
Means.
Oh, yeah.
It's the inverse function of these.
Because you already have the fractions.
We already have the type fraction.
Green ones.
Exactly. So, we're finding an angle measure. That's when we're going to use the inverse functions.
How do you, I don't know.
Okay, you don't have to do anything on the calculator yet.
No, so you don't need to do anything.
This would be something that could be on a non-calculator.
Are you good? You should send me that.
All right, so first thing we have to do is, or first thing I would recommend doing is set up the problem as if you were going to solve it. So we have all the sides. So does it matter if you're using sine, cosine, or tangent to solve? No, because they give you all the possibilities there, right? So we have sine of L, cosine of L, tangent of L. If I was doing sine of L, well, let's go ahead and label these sides. What are the different parts? So what's this side? Adjacent. This is, and this is. So sine of L is going to be, so 21 over 75. Cosine would be, and tangent. So now, again, these aren't set up exactly like that. They're doing the inverse function of each of those. And again, all the inverse function is doing is it's taking out the sine, cosine, or tangent so that the angle's by itself. Again, anytime you already have the ratio, but you're solving for the angle measure, that's when you use the inverse functions. So we're still going to match this up with sine, except we're doing the inverse sine of this, which is the first option there. So that one's good, this one's not. So the fifth one's good, this one's not. And the last one's good, this one's not. Alright? So again, as long as you can set them up, again, it's the same fraction, it's just the fact that we're taking the inverse of each of those ratios in order to get our angle measure. Again, to get an angle measure, that's when you use the inverse function. All right. Again, this could still be on the non-calculated part because on this one, I'm not asking you to solve, I'm just asking you to set it up. So again, this could be on, like, say, one of those equation editor type questions where you have all the different options and you have to write your own equation to set it up. This could be on that type of question. So take a minute, see if you can set this up so that you can solve. Again, still don't need a calculator because we're not solving yet. We're just setting it up to solve.
What did you say?
You guys just don't want to write anything down.
Oh, you can have it.
Where's Allie? Allie. Why so many sets to it? It's for dramatic effect.
I'm just, yeah. you know, he says he has no paper. He didn't ask. He doesn't have a pencil out. So there's plenty of stuff back there in the back of the room. Been there all year long. Who'd you swap with? She doesn't have another shoe on. She just has. No.
Which one is the one? So, scrape that up.
Why didn't you even wear your shoes? You just took somebody else's shoe and put it on. All right. So on this one, what two parts do you have? This is, again, compared to 75. This is opposite. This is hypotenuse.
That makes it an old hippie.
So that makes, so this is sine, right? Sine of 75 degrees equals 10 over p. Again, you could have to type something like that into an equation editor. All right? All right. Now you are going to need a calculator. So you haven't had to use a calculator.
Very demanding. How dare you?
But now on these, you need a calculator. All right? So I actually want you to solve. So first part of this is exactly like the last one. You're going to set it up. But then once you set it up, you got to use a calculator to solve. And I want your answers rounded to the nearest hundredth. Now, I do recommend, again, I don't really care what calculator you use, but I recommend
I'll take the wonky one. Somebody 28 minutes.
these. Now, can you use this one as a handheld on the test? No. But again, you get the gray one, you get this version of the calculator as a handheld. But this one is like the one that's on the computer. So again, I like the one that's on the computer for these types of questions because it makes it easier to type the entire thing in. But again, the preference is still yours. So try those two problems. See what you get.
Hello. Hello. Why do you have your glasses on? Oh, that's right. Future's too bright. No, I'm good. Way to be. I was watching film yesterday with Kitchy. Saw some of your hands. Yeah, you do a good experiment. Friday's already waiting. You go. I'll be there. Alright, good. Kitchy's noticing your hands. Keep it up. Hello. It's Hollywood.
You actually got to play that. And you the wrong
Yeah, okay, so I'm not wrong.
So,
I just determined.
it's not cosine.
Okay.
Not for that one.
Yo, mine's
That's fine. Cosine is adjacent and hypotenuse.
Yes.
Oh, you do know how to write. Yes, you do. You put it into the
That's better.
Yeah, but it's hard. It's like,
Guys, even if you forget how to plug it in, at least try to set these up so I can see if you remember how to do it.
I keep getting a negative number.
you're not copying down the whole problem. Write something down so I can see how you guys are doing.
Okay, I got the one of them done.
Oh well. First one looks good.
Yay! But this one is divided by W.
Alright.
So would you multiply it to get rid of it and then you just kind of let it hover there forever?
So you first have to multiply the W.
Okay, so you do let it hover forever. So it becomes
Hmm?
before or after. Would you write close?
I usually write it in front of it. And then it's give me another step.
Oh, would you divide off the 72?
Well, the cosine of 72.
Oh, now I'm gonna ask for it.
Very specific today, aren't we?
Alright, let's go ahead and go over this because I want to make sure.
Wait.
We got 2 more slides after this. And we got 13 minutes left, so.
Okay, so I think I've done the thing.
Wait, revise it.
Okay.
Alright, I'll give it another minute.
Close to right-ish. What's that? Wait. I did it right. Now I'm going to get a crumb just
Okay.
to spice it.
You know how to
I
start
went
it?
around it wrong.
So, alright, so you have this angle, right? So based on that angle, what 2 parts do you know?
That's okay. That
Okay, so this would be opposite, because it's across from it. This would be adjacent, because it's next to it. So which one would you be using? Okay, yep. So tangent of the angle measure equals x over
Haley.
Oh, you heard it? I'm sorry.
opposite over. So now you can express up. So current is on the bottom, we're dividing that, so multiply it to the other side. You can type that whole thing to calculate.
No, because I took
You got this, Alright. Now, one other thing, real quick, on a problem like this, guys, because, again, I don't know for sure if this will happen, but I have seen it before, so I'm just throwing it out there. Everything, every time we've done one of these problems in class, we've always used degrees. Later on, we talked a little bit about radians. So again, when you solve these problems, you should normally have your calculator in degree mode. In the off chance that you might get a problem where they give you a radian instead of a degree. All right? You can do one of 2 things. You can convert radians to degrees by multiplying by 180 over pi, and then use degrees. Or you could just choose to leave your calculator in radian mode instead of degree mode, and you do everything exactly the same. So again, it's your choice, but it is possible for them to combine things from 2 different sections because, again, later on when we talked about circles, we talked about radians. So they could combine those 2 ideas from trig and that section of circles. All right? Now, for these problems, so let's go ahead and set them up first. This one, which trig ratio are we using? Tangent. Yeah, because we have the angle, we have the opposite, and we have the adjacent. So that would be tangent. So tangent of the angle equals opposite over adjacent. For the other one, for the setup, all right, using the 72. Shh, guys. Shh. Which one are we going to use? Which trig ratio? Cosine, because we have which 2 pieces? Adjacent and hypotenuse. So cosine of 72 equals 6 over W. Now, again, we have to solve both of these. The first one's easier because there's only one step to do. We got to get rid of the 15. So multiply 15 over to the other side. When you do that, you'll have x by itself. And you can plug that whole thing into the calculator. So, again, if you're using a calculator that's going to be on the computer, it's going to be similar to this. And that's why I like using this one for these problems. So 15 times tangent of 24, and you get your answer of 6.67. If you're not used to this type of calculator, I recommend when you go through and do the FSA practice test online, practice using that calculator some so that you're familiar with it. All right? Again, it's on the FSA website for you to practice with. So 6.6784. It says round to the nearest hundredth. I know I didn't round yet. 6.68 would be your final answer. Now, on the other side, there's more steps. First, we do have to get rid of W. So we'd multiply W to both sides because it's on the bottom. We can't have what we're trying to solve for in the denominator. So we'll cancel off, and it's going to go over to the other side. Now we have W times cosine of 72 equals 6. Question?
Why wouldn't we just divide by 6?
Because that's not what ends up happening. Watch. Now these are being multiplied together. So in order to get W by itself, we're actually dividing by cosine of 72.
What? You fancy? No.
I wonder why. Maybe.
All right. So if we plug this into our calculator, it is 6 divided by cosine of 72. So 6 divided by cosine of 72. 19.416, which again rounds off to 19.42. Now, again, one of the reasons why, yes, you can do everything on this calculator, but again, there's extra steps that you have to remember to hit, because when you're doing this one on the calculator, I could type that whole thing in. 6 divided by cosine of 72, you have to enter as 72 cosine. Now, this is currently just the cosine of 72. Although I typed in 6 divided, it hasn't done that yet until I hit equals. Now it's done the complete problem, and now I have the same answer that I had before. So again, you can still use that calculator. You can still type the whole thing in. It's just a matter of you have to remember to make sure you push enter at the end, or make sure you type things in the correct order. All right? Any questions on those two? All right. So then on the next one, very similar, except this is solving for an angle. So try to solve for angle F.
I'm trying to draw on my dragon. That's what you deserve.
I went in so far.
Shame.
I know, I'm just saying.
You would vote my dad.
Do you see this? Look, I'm about it.
Okay, I don't know how to solve myself.
They'll lay right here. They'll lay right here.
There's no way that's the degree.
Please just get the clip.
And I hate it, but no, I'm not.
So do we? Yeah, I don't know. Divided by sign, inverse sign of that. So you can just type it in as inverse sign of 22 over 26. And that'd be the answer. So again,
The thing you have to remember is you're solving for an angle, so you have to use your inverse function here.
Oh.
So again, we have F, we got to set it up, we got this side is Opposite. This side is hypotenuse.
Tangent.
No.
What?
Sine.
Sine, sorry.
Sine of f equals 22 over 26. We got to get f by itself. So we're doing the inverse function of 22 over 26. We got to get rid of sine. So again, opposite of sine is inverse sine. And again, you can plug that whole thing into your calculator. So, second inverse, 22 divided by 26, close my parentheses, equals 57.7957. It says round to the nearest whole number though, so 58 degrees.
I just didn't know how to do it.
Oh my god.
What am I doing?
You just use the inverse.
You good?
You've already told it to like 20 times.
All right. Last one. This one is a word problem. They give you a diagram though. All the information is there in the diagrams. We're just trying to solve for x. So, solve for x.
You got food. You got food.
No. It was a piece of cheese.
You got any more though?
No.
Absolutely. Okay.
Yeah, you heard me. You heard me.
I don't know.
Do you have any more in this class?
What is that?
Yes. Do you have any more in your car?
Oh, that's what you're saying.
We're at home.
There we go.
No. Do you have the option?
See, Mr. Speed, like, I don't need your
Oh, on the original, I didn't copy those. On the original test question, it was multiple choice. I didn't put the multiple choice answers on here. Sorry about that. Yeah. What'd you get? I think that was right. Yeah. All right. So again, just like the last question, we got opposite, we got adjacent. This time we're using tangent. So tangent of x equals 32 over 77. We gotta get rid of tangent, so we're doing the inverse tangent of 32 over 77, which gives us, yeah, normally for angles they usually have you round to a whole number. Inverse tangent of over 77, which is roughly 23 degrees. All right. So again, not giving you a new assignment today. Again, make sure you're getting those 2 online assignments done.